are that high sodium, high calcium, high potassium, high magnesium. They are in percent range, more than 10,000 ppm. And with Perkin Elmer, we do have this paper like direct analysis of trace element in seawater. This is a Perkin Elmer paper published and also code Malaysia Marine Water Quality Standard and Index MMWQS. So we are analyzing it, and just because this sample is so complex that we need to use triple quadruple ICP-MS. It is capable to use oxygen ammonia to do analysis. Because look into the marine water air, there are these elements. There are some elements need to use ammonia. There are some elements need to use oxygen. So it's listed here. Like arsenic is analyzed by arsenic oxide because these are being interfered by chloride. Argon chloride mass 75 interferes with arsenic 75. Therefore, we move precursor ion arsenic 75, product ion arsenic oxide at 91 using oxygen reaction mode in the ICP-MS. In fact, seawater ICP-MS not capable to meet it. Yeah, you must need ICP-MS. So look into it. Calibration of mercury on seawater is 10 ppt. 10 ppt. The rest all in ppb level. So this is the Marine Water Act. Okay, now we move into it. In fact, time is running short. Still got food, still got pharma. Okay, I think never mind because it's a very long topic. In fact, just for maybe one section, it also take. Okay, it doesn't matter. We go for this food act. This is Malaysia Food Act. Look into it like probably we pick the low side. Mercury 0.05. You got mercury, got arsenic, lead, cadmium, antimony. Food can be any kind of form. As long as you want to do mercury, earlier that we do discuss, you need microwave digester. One you need to use microwave, the sample dilution factor is 100 times, at least 100 times. So from 50 ppb, after 100 times dilution, it goes down to 0.5 ppb, which is 500 ppt. So in this case, you need ICP-MS to do it. Unless if you let go mercury element, you are doing 10 times dilution, etching, also acid dilution, then other element, antimony, cadmium, this is 1 ppm, 10 times dilution, going down to 0.1 ppm, which is 100 ppb, ICP-MS can do it. But mercury is not listed in. If you want to be one single run for all elements, including mercury, you must use microwave. And next instrument, because too big sample dilution, ICP-MS come into picture. ICP-OES will not be good enough to do it if you include the mercury. This is MPIA. Pharmaceutical level will be much higher compared to food because supplement drug, we don't take that frequent. Therefore, it's higher, about 10 times higher. So look into it. This is the range for MPIA for traditional herb. This is the egg. And look into it. Arsenic, like fish sample is inorganic arsenic. Okay, what does it mean? That is arsenic 3 and arsenic 5. Mercury got arsenic got many forms, got arsenobutane, MMA, and this sort of thing got a lot of forms. So this technique it is HPLC hyphenated with ICP-MS. It's LC ICP-MS to do arsenic 3, arsenic 5. Same thing as mercury for the fish product, methyl mercury, mercury 2 ethyl mercury, HPLC hyphenated with ICP-MS to do species determination. So apart from food, those are common elements. Is for coloring. Food side include the barium as well. This is the coloring. So these are all the food safety elements. Now, food nutrition like calcium, iodine, iron, magnesium, those are basically in the mean that milligram per 100 gram is about 10 ppm. This is about 1,750 ppm level. So these are the nutrition food labeling is high level. So normally official method listed on ICP-OES, but however ICP also can be done. We can extend to the high range to do it, but official method listed on ICP-OES, ICP also can do. Now Malaysia Act, we move to European Act, Food Act. Meat, they are talking about 0.1 ppm. Malaysia is 2 ppm. It means that European is 20 times lower than Malaysia. Food Act. So we can see that the food safety going lower and lower. So let's say now maybe OES 10 times dilution can do it. Future, if Malaysia Food Act amend it going down lower, ICP-MS just maybe can't meet the level. You need an ICP-MS for toxic elements such as mercury, lead, cadmium. Okay, this is mean that the amendment 208 lead 0.3 ppm. Okay, now cadmium, Malaysia 1, European 0.05 is also 20 times lower. So vegetable, Malaysia 1 is European 0.05. So this is cadmium. This is mercury. In fact, Malaysia and Europe is the same because fish contain high mercury. Yeah, it is. Yeah, because normally sea-based contain mercury, so you don't see fish have low mercury. So for if they bring down lower, they just cannot pass. Okay, now Malaysia, like DSM issue a letter to all the SAM lab to do the food safety sample. Garis panduan analisa makanan for magma swasta. This is by MOH guideline. You can use any method, AOAC, FDA, and this ISO method to do food must be accredited method. And the appendix is listed is AOAC method. So I would say that now everything must be followed. AOAC method, now we move into AOAC method. Look at AOAC method, i-CRIM heavy metal in food for this big four, arsenic, cadmium, lead, mercury in all kind of food is by i-CRIM and microwave, because it contains mercury. So next is iodine. AOAC method is also using Perkin Elmer i-CRIM. AOAC method 2015 is also using Perkin Elmer i-CRIM. AOAC, then iodine official method is also by i-CRIM. Now this is a paper from Perkin Elmer doing iodine, and we are doing the certified value. Certified value measure is the same. Is i-CRIM is a measure. This is the Nestle method for iodine. Okay, now this is methyl mercury from this KKM for MOH on the probably on the journal. Like this is methyl in mercury to methyl mercury. Start from caliber 0.5 ppb to 6 ppb. This is HPLC i-CRIM in this MKAK Magma Kebangsaan Award. Okay, so after the CIM spike the fish. Okay, now this is arsenic species on juice. So this is a sample prep. You got mean the arsenic 3, arsenic 5, arsenic 3, MMA, DMA. So important, these 3 and 5 are highly toxic, run in about 4 minutes. Okay, so now we move into it. 3 NCPD. As you all know, 3 NCPD official method is by GCMS or GCMS-MS. Some people may use LCMS, but you look into it, sample prep may be taking you 2 days to do it. In fact, the other method like i-CRIM, like we are working with local palm oil factory to check precursor chloride, because 3 NCPD is basically form chloride. Chloride heat out, it forms 3 NCPD. So we check the chloride. So in this case, because palm oil, we inject, right? We heat up to 65 degrees. So we are checking on chloride. It's a precursor for 3 NCPD, and it can detect down to about 0.01 ppm. Malaysia MPOB implement 2 ppm for palm oil for 3 NCPD, and this is a precursor. If chloride lower than that, it's okay. No need to run, maybe prepare the sample for 2 days, just run on ICP-MS. Take the sample 10 times dilution and shoot, you can get the result within 5 minutes. It's a precursor anyway. It's screening tool. Yeah, correct. So you can look into it. Recovery is very good, almost 100%. Mass 35, correct. Apart from this correct in palm oil sample, like food safety, we also can do on other food toxic element plus QA, QC for palm oil refinery. So you can look into it, mercury element, this all thing, lead, arsenic can be run one go. Take the refined palm oil, 10 times dilution and run on ICP-MS together with chloride. So that is on the food safety. Now we move into it. Upstream plantation, basically agriculture. Agriculture basically on this your nutrition, plant nutrition, look into it, is basically PKCNG is nutrition help for the plant and also for the soil. So need to check on this element. This is the fertilizer for the PKCNG. For information, like P cannot be analyzed on AA. It needs to be analyzed on ICP-OES. So this is a range on fertilizer. Now this is that the throughput trace nutrient for agricultural soil sample. Basically the sample preparation on soil, because it's you can look into it. These are elements, major element. This is basically the soil health, soil nutrition. Basically on a very high level, you can look into it up to maybe 1000 ppm. So this is a sample. You look into it. This lab it's a very busy lab. This is US agricultural soil lab. So you can look into it. After they run it, they plot the soil, the land, which is mean that deficiency, optimum, mean the excess on the fertilizer. So in this lab, these are the element, 11 crucial element, 30 seconds per sample, 2005 sample soil sample per day. So it's very high throughput lab. So now move into pharmaceutical. Pharmaceutical, look into it. Basically that you look into it, pharmaceutical, it involves a lot of instruments. So I only look into this elemental analysis. Elemental analysis, like for example, this is all the regulation from this is Malaysia. I mean the US pharmacopoeia, this is European monograph and comparison. Basically, we are talking about this for lead, arsenic, cadmium, and mercury. These are the these is various kind of mean that toxic element listed from different requirement. So okay, also we listed BP. Okay, now Malaysia MPRA is listed on this. Same thing as here. You contain mercury at 0.5. You look into ppm, maybe ICP-OES can do it. Well, fine. But you contain mercury. If using normal acid dilution, mercury loss in the sample prep, you won't detect. It's not because it's not there. It's lost during sample prep. Therefore, if this is 0.5 ppm, is 500 ppb. After 100 times dilution, it goes down to 5 ppb. The first point calibration for the instrument, it should be 10 times lower, 0.5 ppb. So in this case, the proper and good method will be still ICP-MS. Even though you want to use ICP-OES, you have to really play around, reduce the dilution factor and here and there, and also mercury is also a concern, because if using other method for mercury, it may not be validated method. So this is cosmetic. It's listed on the element, is slightly different from this traditional herb. Okay, now this is Perkin paper on ICP-MS. This is CP, Chinese Pharmacopoeia 2020. Compared to Malaysia, because every country for traditional herb, they want to be lower and lower. Malaysia follow WHO. So that Malaysia 5, China 2. Malaysia quite the same. This is 0.5 mercury, China implement 2. 10 ppm, 5 ppm. So all the country want to be lower because of toxic elements similar to US and also Europe. Malaysia follow WHO. So this is ICA, is International Conference on Harmonization, because tradition, this pharmaceutical, Malaysia, our air a little bit different from Singapore. Even Southeast Asia is not harmonized. Europe and America also different. So now they want to come up to harmonize, to be standardized. This is US pharmacopoeia. US pharma. It listed the element. Malaysia look at big four. This big four. But they are looking for so many elements, list of 24 elements. Because basically developed country, they want to know more elements. Maybe during processing, it may pick up some other element as well, from the tank, from the container, from the machine. So they're checking all elements across all the drug. So at the moment, Malaysia not be implement on this USP yet. If your product need to export to US or Europe, you need to follow ICH or USP. So these are the elements need to be aware of. So this is US EPA for drug product, listed the element and the range. And look into it, USP listed inorganic arsenic, inorganic mercury. It means that arsenic 3, arsenic 5, and methyl mercury to inorganic mercury. So this is the different. Supposed to be LC-ICP-MS, but you do total pass, you no need to do species. If total fail, you need to do species to pass your sample. Yeah. So this is Perkin paper, supplement nutrition also contain big four toxic element. This is USP. These are the element. It got oral, parental, inhalation. This USP is listed, all the range is on ICP-MS. USB is on ICP-MS, and 233 is mean that this is 232 is on metal. 233 is basically on validation method like accuracy, repeatability, ruggedness, stability. Okay, this is British pharmacopoeia, element different. You can look into it. It's still using AAN. So US move very fast. You follow, let's say BP or European is still using AA. So now let's say develop and US is move very fast. So still you need to use hydride because I mean that affordable. Put in this way, affordable. So I think that these I would say that maybe it's time to break. I will continue in at 10 p.m. Now it's a short break for you all. Okay, yeah. So I will come back at maybe a short while, about 5 minutes later for you all for biological break. Okay, yeah.
Okay, let's have a break for a while. We will continue after 10 minutes, and please enjoy the video from i-CRIM. Thank you.
Centralised Laboratory was officially founded in 2007. i-CRIM Centralised Laboratory provides technical and consultation services to scientific communities. In i-CRIM Centralised Laboratory, we have three main labs: Molecular Structure Characterization Lab, Physical Characterization Lab, Morphology Lab. Each lab is equipped with high-end instruments and run by well-trained personnel. i-CRIM Centralised Laboratory offers a wide range of technical analysis, especially in material sciences, mineral studies and elemental analysis, surface analysis, caffeine analysis. Molecular Structure Characterization Lab is equipped with liquid chromatography mass spectrometer (TOF), nuclear magnetic resonance (NMR), gas chromatography mass spectrometer, automatic polarimeter, FTIR, HPLC. Physical Characterization Lab is equipped with Auger electron spectroscopy with XPS, single crystal XRD, X-ray fluorescence, X-ray diffractometer, photoluminescence, surface profiler, ultraviolet BIS. Morphology lab is equipped with field emission scanning electron microscope (FESEM), particle size analyzer, scanning probe microscope, atomic force microscope. i-CRIM strives to provide our clients with quality scientific and technical services, capacity building, competitive rates. For more information, please visit our website at www.ukm.my/i-CRIM. Welcome to i-CRIM Centralised Laboratory, University Kebangsaan Malaysia. i-CRIM Centralised Laboratory was officially founded in 2007. i-CRIM Centralised Laboratory provides technical and consultation services to scientific communities. In i-CRIM Centralised Laboratory, we have three main labs: Molecular Structure Characterization Lab, Physical Characterization Lab, Morphology Lab. Each lab is equipped with high-end instruments and run by well-trained personnel. i-CRIM Centralised Laboratory offers a wide range of technical analysis, especially in material sciences, mineral studies and elemental analysis, surface analysis, caffeine analysis. Molecular Structure Characterization Lab is equipped with liquid chromatography mass spectrometer, TOF, nuclear magnetic resonance, NMR, gas chromatography mass spectrometer, automatic polarimeter, FTIR, HPLC. Physical Characterization Lab is equipped with Auger electron spectroscopy with XPS, single crystal XRD, X-ray fluorescence, X-ray diffractometer, photoluminescence, surface profiler, ultraviolet BIS. Morphology Lab is equipped with field emission scanning electron microscope (FESEM), particle size analyzer, scanning probe microscope, atomic force microscope. i-CRIM strives to provide our clients with quality scientific and technical services, capacity building, competitive rates. For more information, please visit our website at www.ukm.my/i-CRIM.
Okay, Mr. Ng, you may want to continue the presentation.
You can see the screen. You can see your chemical REE application.
Yes, clearly.
Okay, fine, good. Okay.
Sorry, Mr. Ng.
Yes.
I think this is presenter mode.
Sorry, I don't get you.
This is presenter mode, isn't it? Or is it a slideshow?
Slideshow. No. It's a slideshow.
Okay.
Slide. That one, the video will be the third section. Yeah.
My screen is showing it's a presenter mode. So
presenter mode now.
So
Okay.
display settings and
okay.
okay, this is okay.
Okay, fine. Good.
All right.
Okay.
Thank you.
Your chemical and application. Okay. Good morning to everyone. Okay. We continue for the section 2 for your chemical and REE application. Okay. For geological sample, this is the sample that it can be analyzed by ICP-MS. For example, this is the sample. We are using ICP-MS to analyzing your chemical sample. Okay, so ICP-MS is basically the fast sample to sample, mean that high productivity, and also mean that we can put in, mean that it can go for high concentration. Okay, so look at the element of this. This is the CIM. Basically, it's a sediment sample from this National Geophysical Institute in China. That on top element.
Lagi wayar bawah ni dia tak keluar, kita boleh pakai. Thank you.
Okay. So on top element, basically on ppm level. For example, zinc, vanadium, titanium. Titanium is rather high. So for your chemical sample, it consists of ppm level as well as percentage level on the below. Look at aluminum, iron, magnesium, K, sodium, calcium are in basically percentage. 1%, we are talking about 10,000 ppm. So look at this case. If to run on ICP-MS or ICP-MS, if the lab, let's say it's very dusty, basically that these are the environmental contaminants such as aluminum, iron can contaminate the sample. Therefore, for atomic spectroscopy like ICP-MS, ICP-MS in bracket, keep the room or rather maybe clean. If let's say the room itself is do not maintain clean, these are the elements it may go inside the sample to be analyzed as from sample, but in fact maybe from surrounding, from table, dust, because this is basically is element from soil. Very easy to contaminate. Yeah. So this is on ICP-MS. Basically on ICP-MS, we will look into it, the calibration on this element, because this element usually will be low. About mean that below 1 ppm calibration, this is about below 20, and these are the element for 500 ppm level. In actual is maybe percentage, but after sample prep, it go down to a few hundred ppm, level. So to be analyzed on ICP-MS. So this is your chemical sample, and the result will be displayed in this manner. For example, this is the calibration. This is mean that it will plot. If click on here, it will show this is the graph. So it will show mean that what is the error of the calibration. Every point mean that plus minus for how many percent. So this is from the result. In case if you put in, let's say upper and lower limit from set, let's say plus minus 10%. So from the here result here will turn to red color straight away. You look at the color, you know that which one is fill your QC. So now the software very advanced. You put in the level, it will be able to monitor for you by color. So this is run on, let's say, different kind of sediment. Check on the recovery is very good. I mean that within 10% across all the elements for this geological sample cover from as high percentage level as low as ppm level. So this is on accuracy. Now we are looking at the stability, long-term stability. We also can monitor on this internal standard, the drifting of internal standard. So now we also look at this, the stability of this element, like for most element 0.4 ppm, but these are the major element normally present in the soil very high, 100 ppm. So monitor for about 8-hour running stability is within plus minus 10% for multi-element analysis. This is the